Welcome to The Explainer. We've got something absolutely mind-bending to dive into today. We're going to take a journey together that starts with just one single, unassuming photograph and somehow ends up generating an entire simulated universe. It is a brilliant example of just how much hidden data is floating around in those everyday moments we constantly capture on our phones and how modern analytical tools can extract some truly incredible insights from them.
I mean, think about it for a second. What can a single 729 kilobyte group selfie actually teach us about complex human behavior? It's just a tiny little file. It's an everyday moment, the kind of photo you might quickly snap with some colleagues and then totally forget about by the next day. At first glance, there is absolutely zero scientific data there. But the answer is going to blow your mind. It can build an entire mathematical universe. Through the power of advanced modeling, that one frozen moment in time can literally be decoded and expanded into a dynamic, living, breathing simulation of human social interaction. It's just an incredible transformation from this totally mundane input to a massive, complex output.
Okay, let's dive into part one, from selfie to simulation.
So let's look at what we're actually starting with here, our input. We're working with a basic 729 kilobyte JPEG. In it, we see 4 individuals taking a group selfie. They've got visible name badges, which kind of hints at a startup or networking event, and they're standing in your standard conference room setting. And that's it. There's zero quantitative data here. No scientific paper attached, no spreadsheets, no complex equations. And honestly, that stark lack of scientific data makes what the AI systems at DBbun LLC were able to pull out of it all the more impressive.
Moving on to section 2, building the networking sandbox. So how on earth do we get from that simple image to a complex model? Well, the back-end technology that Claude Sonnet 4.6 used to build this simulator is called agent-based modeling. You can kind of think of it like a video game simulation, like The Sims, but for behavioral science. It's a computational framework that simulates the actions and interactions of autonomous individuals, which we call agents, to understand how the whole system behaves. It's basically the perfect tool to simulate small group interactions, networking behavior, and encounter rates, all based on that single photo. To get this sandbox up and running, the system established 20 total parameters. And what's really fascinating is the difference between the extracted and assumed values. The simulator literally looked at the photo and extracted the hard fact that there were 2 display screens visible in the room. Then, based on the context, it assumed a baseline of 80 total attendees. We also see variables like a mean extroversion score set at 0.6, which acts as the real engine of networking for our agents. There's even a selfie probability, the chance that a group of 3 to 5 people will stop and take a selfie, which is directly inspired by the original image itself.
All right, section 3, running the scenarios.
Now that our sandbox is built and the parameters are locked in, it's time to tweak the event's DNA and test out some alternate realities. The simulation didn't just run once, it ran 5 distinct scenarios to see how different variables change human behavior. First up, event density. We've got a baseline networking event with 80 attendees over 2 hours, with a natural mix of roles. Then we have a high-density event that doubles the crowd to 160 attendees in the exact same venue size. We're testing a very practical question here. Does packing a room full of people actually improve your networking quality, or does it just create chaos?
We can also do a bit of a vibe check on the event. The simulator tested a short mixer. Picture a rapid-fire 30-minute speed networking setup where the base interaction probability is really cranked up. Compare that to an introverted crowd scenario, where the mean extroversion drops way down to 0.3, resulting in much slower, quieter interactions. This just highlights the unbelievable flexibility of the agent-based model to simulate totally different social atmospheres.
And the results of these scenarios on how groups form? Absolutely fascinating. The data tracking the mean active group size over the 120-minute event shows that, regardless of the scenario, groups form fast, and then they stabilize right between 2 and 4 people. Now, if you look at the observed group size from the original selfie, it was exactly 4 people. So the simulation perfectly validates the natural 4-person group dynamic we saw in that single 729 kilobyte file. How cool is that?
Section 4, visualizing social dynamics. We are now moving into the visual payoff. The simulator produced over 100,000 rows of synthetic CSV data, and we get to see how that massive wall of numbers translates into highly recognizable human behavior. What's really interesting here is how personality drives networking. When we plot an agent's extroversion against their final number of connections, the trend shows exactly what you'd expect. Higher extroversion equals more connections. But look at the founders and investors. Many of them sit way above the normal trend line. Why? Because the model includes a role affinity boost.
People naturally flock to founders and investors at startup events, giving them a massive networking advantage regardless of how extroverted they actually are.
Looking at the overall distribution of these connections across the different scenarios, we see this distinct right-skewed shape. The massive clusters show that the vast majority of attendees make a moderate, pretty average number of connections. But there's this long tail extending out. That represents your highly extroverted hub individuals who are literally dominating the room, making 25, 30, or even 35 connections, especially in the high-density scenarios. Let's see how this builds in physical space. When we look at a 2D spatial heat map of the agents at the 60-minute mark, the brighter the color, the higher the density of people. See those two distinct, bright hotspots? Those are actually the display screens. The model extracted the two screens from the background of the original photograph and used them as social anchors, proving that venue layout creates undeniable spatial clustering. We naturally gravitate toward screens and form crowds around them.
Now, this next metric is honestly brilliant. It tracks cumulative selfie events. It's a playful, stochastic metric inspired directly by the source image, and it acts as a proxy for peak social cohesion. The data shows that the high-density scenario skyrockets compared to the others. It tells us that higher density and elevated encounter rates lead to a room reaching its peak social cohesion the fastest.
And finally, Section 5, the synthetic data advantage. So, we've seen the incredible data generated from this one photo. But why does any of this actually matter? Well, there are very tangible, real-world benefits to these synthetically generated figures. Event organizers can use this exact sandbox to test guest list sizes and see if a bigger crowd actually yields better networking. Social scientists get a reproducible baseline for modeling human interaction. Venue designers can use those heat maps to figure out the optimal placement of refreshment stations or sponsor booths to prevent bottlenecks. And crucially, for privacy advocates, this allows us to train models and analyze social graphs without the creepy implications of tracking real physical attendees with surveillance. But here is the absolutely crucial takeaway, summarized perfectly by a disclaimer from DBbun LLC. These outputs are synthetically generated artifacts computationally inspired by the source content. I really want to emphasize that word, inspired. This incredible tool is computationally inspired science. It is not a literal, creepy recording of real people at a real event. It takes the DNA of a moment and it builds a hypothetical universe from it.
Which leaves us with a pretty wild final thought. If a single, unassuming, candid photograph can be used to simulate an entire room's complex social dynamics, what other hidden worlds are just waiting to be decoded? The next time you snap a quick photo, remember, you aren't just capturing an image. You might just be capturing the blueprint for an entire mathematical universe. Thanks for joining me on this explainer, and keep looking for the data hidden in plain sight.